Earth science is the study of the nature and evolution of the Earth. At HKU, we have scientists working in all different areas of earth sciences, including groundwater and coastal environments, climate change, change in the continents over geological timescales, and environmental issues. To put the Earth in context, we need to understand the other planets in our solar system, as well as the thousands of extrasolar planetary systems that we have now discovered. We know that as a consequence of their formation process, volcanic activities is a widespread phenomenon, including on our own Earth.
Volcanism is key to understanding the Earth. It's the main mechanism by which rocks form. Between about 170 million years ago and about 140 million years ago, Hong Kong was a plate tectonic boundary. We had a large amount of volcanic activity, and we can see this at the Lai Chi Chong section, where we have these spectacular accumulations of volcanic strata. Plate tectonics involves the study of Earth's dynamic shell, so we can look at the distribution of mineral deposits, or from another issue is looking at earthquakes and the hazard issue. Because of my interest in biogeography, I'm very interested in the land-sea interface and the geological past. And a key aspect of that is looking at relative sea level.
I try to understand processes that drive coastal change, so in particular, relative sea level change. Mangroves grow in the intertidal zone, so very close to sea level. So if you find evidence of mangroves further inland or below present, it gives you an idea of how sea level has changed through time. So this is a mud sample that we collected from the mangrove, and what we're going to do is pass it through this settling column to separate out the microfossils from the mud. And the microfossils are key for telling the story of the shoreline and sea level. So these species that you see here, they like to live in the mudflat setting. And then if we look further up in the core, we see another set of species that like to live in mangrove environments. It suggests that mangroves have been prograding out or advancing further into the sea.
Mangroves are recognized to be one of the special ecosystems where plastic debris can be trapped, and we can have a high abundance of microplastic. Most of my research focuses on how plastic polymer is impacting the ocean ecosystem. So in Aberdeen, we are deploying plastic pieces, and we are looking at how they degrade. So we want to understand how fast and the difference between the different types of plastic. So one way to look at the plastic fragmentation and degradation processes is to look at how the plastic nanostructure change by spending time in the water.
The goal of this research is to have the scientific background to say we should ban this type of plastic, or we should limit its usage, or we should do a better recycling of plastic that create the fastest the microplastic, and then they are the more damageable for the ocean. My message, please use less plastic.
One of the great frontiers in geoscience research pertains to scales. We understand better than ever now things at the nanoscale and microscale affect things at the field scale and human scale, and at the global scale, as we see from remote sensing data. Remote sensing is a fundamental part of all fields of modern-day geoscience. The same technology we use to map microplastics in the laboratory, we use to map microscale mineralogy that we apply to remote sensing of Mars. Earth Sciences offers immense opportunity for the best students around the globe to join us as we explore from the early Earth to deep space to developing a sustainable environment. Looking back at the Earth from space, it's clear that this planet is one giant geosystem, and we're all a part of it.